In this video, we're going to talk about factor by grouping. Now, first, we're going to approach it with an example. We have that we want to write the polynomial in factored form by factoring out the GCF. We have this lovely polynomial here. If you notice, we have this same binomial in both places. This is called a common binomial. In essence, what it is it is the GCF of each of the two spots. So they've actually already done the hard part for you in this example. They've already factored out the GCF. They've done that. So all that's left is to put it into the factored form, which involves bringing down the common binomial, the 2b plus 7, into its own set of just the 1. And we're also going to bring down the rest of it. And the rest, the a squared here, and we also have an invisible 1 there in the middle with the negative. So we'll have the minus 1. And we're going to write that in its own set of parentheses. I call this the squish step, because we're taking a long thing and we're pushing it into two sets of parentheses. So we're just squishing them together. So our final factored form of this polynomial would be a squared minus 1 2b plus 7 as one thing. Now, factor by grouping itself is a process of factoring that is very specific to 4 terms. If you have a 4-term polynomial, then you will factor by grouping. And mathematicians, not that creative when it comes to naming things, so what we're going to do for factor by grouping is the first thing we're going to do is to group. And we're grouping them into pairs. So we have the first pair and the second pair. And now we're going to factor out the GCF of each pair. Okay, so the GCF of 2x squared minus 10x, all by itself, well, that would be 2x, right? And we're going to divide each of the terms by that GCF. So we get our GCF of 2x, and then the leftovers here would be x minus 5, right? Because anything over itself is 1, so we got the 2's over 2's is 1, and the x's over x's is 1. And now the same thing for the second pair. Right? So the GCF between 3xy and 15y, well, that would be 3y. Remember, the GCF is the multiple that they both have in common. So 3xy divided by 3y and 15y divided by 3y. Leaves us with anything over itself is 1, so those 3's cancel, those y's cancel, those y's cancel, leaving us with x minus 5 again. This is a good thing. We have a common binomial again. So this is actually exactly like the first example in our video. This is a common binomial again, which is a very good thing. We could not do our squish step without a common binomial. But now that we have a common binomial, we can. So we rewrite the two GCFs, the 2x and the 3y, into its own set of parentheses, and the x minus 5 into its own set of parentheses. So our factored form is this: the 2x plus 3y, x minus 5. Let's do another. We have 4 terms again, so we factor by grouping. So we're going to group into pairs, and we're going to factor the GCF of each pair. So the GCF of my first pair here, t cubed plus 2t squared, well, that would be t squared. And divide each of our terms here by that GCF. What do we get for our leftovers? Well, subtract the exponent, so 3 minus 2 would be just t to the first, or just t, plus 2, and anything over itself is 1, so those two t squareds cancel. And what about this second pair? What did we say when we had a negative in front for GCFs? We're going to bring it with us for our GCF. So this GCF will not just be 3, it will be negative 3. All right, negative 3. And dividing each of these two terms by negative 3, we will get negative divided by negative is a positive t plus 2. This gives us our common binomial, which is excellent. So now we can squish them together. So we'll have t squared minus 3 in its own set of parentheses. And then we're squishing the two binomials into its own set of parentheses, just like that. Now let's look at this last example. We have 4 terms, so we factor by grouping. But take a look. When we group these as they are, there's no GCF for this first set. And so its GCF would just be 1. Whenever we don't have a GCF, then it is the trivial GCF of 1. And we get y squared plus 3y. And then the GCF of the second pair would be y. But what happens? We get 3 plus x as our leftovers on that one. It's not a common binomial. It doesn't work. So what are we going to do if we don't have a common binomial after we've factored out the GCFs? Well, we have 2 options. Either our math is wrong, and we go back and fix it. Well, our math isn't wrong here. Or maybe it's not factorable. Well, that is possible. But there is one last option. Let's try rewriting it. So instead of y squared plus 3x plus 3y plus xy, let's rewrite this. Let's try y squared plus 3y plus xy plus 3x. So I switched my terms around a little. So does that work? Let's see. So group and factor out a GCF. So a GCF of this first pair would be y. Divide each by y. So we get y plus 3 there. And GCF of my second pair would be x. So what do we get for its binomial? Well, let's see. We got y plus 3. Okay, now we have a common binomial. Excellent. So we can squish. So our final answer for a factored form would be y plus x, y plus 3.